Module 3, Geometry and Measurement. Question 1. Miki is planning a gap year in Japan. She will store some of her belongings in a small storage box while she is away. This small storage box is in the shape of a rectangular prism. The diagram below shows that the dimensions of the small storage box are 40 by 19 by 32 centimeters. The lid of the small storage box is labeled on the diagram above. Part AI. What is the surface area of the lid in square centimeters? The lid is in the shape of a rectangle, and as we know, the area of the rectangle is equal to the length times width. The length of the lid is 40 centimeters and its width is 19 centimeters. So the area is equal to 40 times 19, which is 760 centimeters squared. This question is worth 1 mark for the correct answer. Part 2I. What is the total outside surface area of this storage box, including the lid and base, in square centimeters? The area of the lid is equal to the area of the base equals 760 centimeters squared. The area of the left side is equal to the area of the right side equals 19 times 32, which is 608 centimeters squared. Area of the front is equal to the area of the back equals 40 times 32, which is 1280 centimeters squared. Now the total area is equal to 2 times 760 plus 2 times 608 plus 2 times 1280, which is 5296 centimeters squared. This question is worth 1 mark for the correct answer. Part B. Miki has a large storage box that is also a rectangular prism. The large storage box and the small storage box are similar in shape. The volume of the large storage box is 8 times the volume of the small storage box. The length of the small storage box is 40 centimeters. What is the length of the large storage box in centimeters? We start from the fact that the volume of the large storage box is equal to 8 times the volume of the small storage box. 8 can also be written as 2 to the power of 3, which means that the linear scale factor in this case is 2. So the length of the large storage box is equal to 2 times the length of the small storage box. That is 2 times 40, which is 80 centimeters. This question is worth 1 mark for the correct answer. From the 2017 VCAA examination report, this question was not answered well. Many students did not calculate the linear scale factor of 2 and gave an answer of 320 centimeters. Question 2. Miki will travel from Melbourne to Tokyo on Wednesday, 20th of December. The flight will leave Melbourne at 11:20 a.m. and will take 10 hours and 40 minutes to reach Tokyo. The time difference between Melbourne and Tokyo is 2 hours at that time of year. Part A. On what day and at what time will Miki arrive in Tokyo? Let's calculate the Melbourne time. That is 11:20 plus 10 hours 40, the flight, is equal to 2160. 60 minutes equals 1 hour, so this is equal to 22. Tokyo time is 22 take away 2 because Tokyo is 2 hours behind Melbourne since it is closer to east. So this gives us 20. 20 minus 12 is equal to 8, which is 8 p.m. So Miki will arrive in Tokyo on Wednesday at 8 p.m. This question is worth 1 mark for the correct answer. Miki will travel by train from Tokyo to Nemuro and she will stay in a hostel when she arrives. The hostel is located 186 meters north and 50 meters west of Nemuro railway station. Part BI. What distance will Mickey have to walk if she were to walk in a straight line from the Nemuro railway station to the hostel? Let's draw a diagram. From the Nemuro railway station, we go 186 meters north and 50 meters west. And here is the hostel. The direct distance between the railway station and the hostel is the hypotenuse of this right-angled triangle, and we label this with x. Using Pythagoras Theorem, x equals square root of 50 squared plus 186 squared, which is, correct to the nearest meter, equal to 193 meters. This question is worth 1 mark for the correct answer. Part 2I. What is the 3-figure bearing of the hostel from the Nemuro railway station? We are going to use the same diagram, and here is the bearing of the hostel from the Nemuro railway station. We can calculate the value of angle theta in the right-angled triangle as shown. Tangent theta equals opposite over adjacent, which is 50 over 186. This means that theta equals 10 to minus 1 of 50 over 186, which is 15.046 degrees. Now we can calculate the bearing required, which is equal to 360 minus theta, and that gives us an angle of 345 degrees, correct to the nearest degree. This question is worth 1 mark for the correct answer. From the 2017 VCAA examination report, this question was not answered well. Some students gave 0.15 degrees. North 15 degrees west is not a 3-figure bearing and was not accepted. The city of Nemuro is located 43 degrees north and 145 degrees east. Assume that the radius of Earth is 6,400 kilometers. Part C. The small circle of Earth at latitude 43 degrees north is shown in the diagram below. What is the radius of the small circle of Earth at latitude 43 degrees north? We are going to start by labeling the radius of the small circle with R, and then place Nemuro on this diagram. The angle shown is 43 degrees, so we can now construct a right-angled triangle. We are going to use this right-angled triangle to calculate the radius. The hypotenuse of the right-angled triangle is 6,400 kilometers because this is one of the radii of Earth. So cos 43 degrees equals radius over 6,400. So the radius equals 6,400 times cos 43 degrees, and correct to the nearest kilometer, this is 4,681 kilometers. This question is worth 1 mark for the correct answer. Part D. Find the shortest great circle distance between Melbourne and Nemuro. First of all, let's place Melbourne on this diagram. Melbourne is 38 degrees south. So the angle between the two radii is 43 plus 38, which is 81 degrees. The length of the arc equals 2 pi times 6,400 times 81 degrees over 360 degrees. And this gives us 9,048 kilometers. This question is worth 1 mark for the correct answer. Question 3. The hostel buildings are arranged around a grassed area. The grassed area is shown shaded in the diagram below. The grassed area is made up of a square overlapping a circle. The square has side lengths of 65 meters. The circle has a radius of 50 meters. An angle theta is also shown on the diagram. Part A. Use the cosine rule to show that the angle theta, correct to the nearest degree, is equal to 81 degrees. We are going to use the triangle formed by the three dotted lines with side lengths 50 meters, 50 meters, and 65 meters. Using the cosine rule, we have 65 squared equals 50 squared plus 50 squared minus 2 times 50 times 50 times cos theta. Doing the appropriate calculations, we have theta equals 81.0832 degrees. Correct to the nearest degree, this is 81 degrees as required. This question is worth 1 mark, and the mark is for the correct method with the correct answer. Part B. What is the perimeter in meters of the entire grassed area? This shape has 3 sides of length 65 meters, and we need to calculate the length of the arc. The length of the arc is equal to 2 pi r times the angle at the center, which is 360 minus 81, divided by 360 degrees. And this is equal to 243.47 meters. So the perimeter equals 3 times 65 plus 243.47. Correct to the nearest meter, this equals 438 meters. This question is worth 1 mark for the correct answer. Part C. The hostel's management is planning to build a pathway from point A to point B, as shown on the diagram below. Calculate the length in meters of the planned pathway. We are going to start with the first part from A to the center of the circle, which is 50 meters, and then the length of the square, which is 65 meters. So there is a little bit that we need to calculate, that is h. We are going to use Pythagoras Theorem in this right angle triangle. H equals square root of 50 squared minus 32.5 squared, which is 37.9967. So AB equals 50 plus 65 plus 37.9967, which is 153 meters, correct to the nearest meter. This question is worth 2 marks. 1 mark would be for the correct answer, and another mark for an additional correct step. From the 2017 VCAA examination report, this question was not answered well. Some students made an incorrect assumption about the distance in the square-circle overlap.